Here's a solution to ECE 321 Analog Electronics, quiz number 1 for fall 2021. The first problem is given an op-amp circuit, write n equations for n unknowns. You don't have to solve, just write the equations. Presumably with MATLAB, you can then set it up in matrix form and solve. To start with, for an op-amp with negative feedback, V plus equals V minus. So I know that V1 equals V2 and V4 equals V5. That's actually the output equation. So node 3 is taken care of and node 6 taken care of. For op-amps, I would like to write the node equation at the output, but I can't because I have no idea what the current is from the op-amp. The op-amp can source or sink whatever it takes to force V plus to be V minus. So these currents, I don't know what they are. And likewise, I can't write the node equations if I don't know what one of the currents are. So V plus equals V minus is the output equation. The other equations are at node 1, the current left plus the current right equals 0. Current into the input of the op-amps is going to be 0. At node 2, current left, current right equals 0. Node 3 we already did, that's V plus equals V minus. Node 4, current left plus the current right equals 0. Node 5, there's actually 3 terms, current left, current up, and current down equals 0. And node 6 we already did. That's V plus equals V minus. So these should be the equations you get. 6 nodes, 6 equations, 6 unknowns. Problem number 2. Find y as a function of a and b. So to do this, the trick is to recognize the different circuits. This right here is an inverting summing amplifier. So I know x is minus r over 500 times a minus r over 800 times b. Gives you the first equation. Second equation, w is a function of c and x. And so w is equal to, if I were to ground x, it's going to be 3, or what I'm measuring across, 2 over the total, 2 plus 3 is 5, 2/5 of c, plus if I ground C and apply 1 volt at X, it's going to be 3/5 of X. And kind of note that if C is 1 volt, X is 1 volt, W is going to be 1 volt. So 2/5 plus 3/5 is 1, that checks out. Y is a non-inverting amplifier. Y is equal to 1 plus the ratio. 5 to 1 gives you 6 times W. Put the 3 together, and I'll wind up with the equation of y is a function of a, b, and c. If R is 1614 ohms, what you wind up with is minus 11.6a minus 7.26b plus 2.4c. That's problem 2. Problem 3. Design a circuit to implement 5a plus 2b plus 7c. And here there's multiple solutions. One approach is create a dummy variable x that's the weighted average of a, b, and c. 5 plus 2 plus 7 is 14. So if I divide by 14, I get this circuit. Again, kind of the check. If a, b, and c are all 1 volt, I ought to get 1 volt out. So that's where the 14 comes from. To clear the denominator, I want a gain of 14. So add a non-inverting amplifier with a gain of 14. Gives you 1 plus the ratio, 13 to 1. And now y is 14 times x, or y is 5a plus 2b plus 7c. Problem 4. If I change the sign on C, there's a couple solutions. What a couple people did, which is actually a good idea, is just take the previous answer and add to it. If I throw in an inverting amplifier, like this, so that goes here, here's your minus input, there's plus, plus goes to ground, make this 1K and 1K, and make this C, that becomes minus C. I now have 5a plus 2b minus 7c. That's one perfectly valid solution. Another way to do it is you could use inverting amplifiers. Here this has a gain of minus 5a minus 2 times b at x. Throw that through a second inverting amplifier, gives you double negative, plus 5a plus 2b minus 7c. multiple ways of doing it. Problem 5. This is a push-pull amplifier. If the input is 3 volts, find the voltages and currents. The first thing I know is V plus equals V minus, so this has to be 3 volts. So V3 is 3 volts. This is, well, by voltage division, V3 is R over R plus 4K times V2. So V2 is 1 plus the ratio times V3. Or you can also say this is a non-inverting amplifier. The gain is 1 plus the ratio times 3 volts. 1 plus 4K over R is 10.43 volts. V2 is 10.43 volts. This is a diode, so I have a 0.7 volt drop across the diode, making this 11.13 volts. In terms of currents, I5 is going to be 10.43 volts over 8 ohms plus 10.43 volts over R plus 4K, gives you 6.498 milliamps, actually 1306 milliamps. That's, I got these backwards. That's I5. And then the current over here, this is the emitter current. The base current is the emitter over beta plus 1. It'll be this divided by 201. So again, this is I5, this is I4. Problem 6. Let's see, what do we do? Oh, this is another type of push-pull amplifier. This is the one that Electroboom used in his video. To analyze it, and this is one you haven't seen before, but you should be able to analyze it. I know that V plus equals V minus, so V1 is 0 volts. 2 volts to 0 volts gives you 2 milliamps for I4, so this is 2 milliamps. This current has no place to go except through I5. This is also 2 milliamps. From V equals IR, I can calculate the voltage, and it'll be 2 milliamps times R negative, minus 3.228 volts for the R that I used, 1614 ohms. Minus 3.228 volts over 8 ohms means that I7 is 403 milliamps. This is 403 milliamps. That's going up. I've got 2 milliamps coming in. Those two add together to I8. So I8 is 405 milliamps. That's the current in the emitter. This is kind of splits. This part is 200 parts because of beta. This is 1 part. So I6 is I8 over 201, which is going to give you 2.01 milliamps going backwards, minus 2.01 milliamps. So the answers are V1 equals 0, V2 is minus 3.98 volts, V3 is minus 3.22 volts, I4 equals I5 is 2 milliamps, and I6 is minus 2 milliamps. That's quiz number 1 for ECE 321 for fall 2021.